This is DeviceNet project number 2, and what we're going to do is we're going to put .io on the DeviceNet so we can control the variable speed controller to make the 3-phase motor run. So we've connected a 1734 AND to the DeviceNet. That took about an hour worth of wiring to do, and now we're going to configure it to control the PowerFlex 40 over the DeviceNet. And then we're going to go and write the 5000 program so it actually works by adding it to our project number 1. So that's the plan. So the first thing we need to do is come up on DeviceNet, RS network for the DeviceNet. And we're going to come up with a new program, so we'll get out of what was there before. And first thing we're going to need is a subnet for the .io, IO being input and output. So we're going to go looking for it, and with a little bit of luck it's there. And it's probably 25. In fact, I know it's 25, so I'll just click on 25 because that's what I set it to. Notice that the OK came on, and I could say OK. So if I picked the 12 guy instead, if I can get control back, if I went to the 12 guy, I don't see anything. So there's nothing at the 12 node right now. Okay, so the 25 node's the right guy. And we see that we have a DeviceNet scanner, .io scanner, and we have a 4-point DC sync input and a 2-point DC sync input. We're going to go look for the rest of them, but they're not there. Okay, so we have them in. Now we're going to go network, upload from the network. And what this does is bring in all the information for those particular devices into the .io, all the parameters, so we don't have to put them on ourselves. Okay, now we're going to do, well, we'll come and look at this guy for a moment, and we see his properties, and we see that he's a Rev 3.013, which we could have looked at. He's at address 1. He has certain parameters. He's currently in the off condition, and he has input-output data. And isn't that lovely? Little bit of luck, that was all done right. All right, so we're going to look at the properties of the scanner, and we look at it. And the first thing we're going to look at is its scan list, and we see that there's a mismatch on the scan list between the guy in port 2. So we'll go update that key, see if that updated. Okay, so now it seems that we have updated the key. Everybody's on the scan list. Our inputs are where they should be because that's where they put them. Our outputs are where they should be because we don't have any outputs. And everything seems to be fine. We'll look at the input-output parameters for a moment, and it's in change of state. Bit size is 1, which is probably correct. Maybe we'll store those sizes just to make sure. Yeah, so that should be fine. Okay, so we're gonna say apply. So we'll download those changes. We're gonna go and we're gonna save this as a subnet of the network, and we're gonna have to put that in the next network file we made. Okay, so I'm gonna save this as, and we'll call it project 2. Project 2 DeviceNet subnet. Doug, so I know it's me. Okay, so we have that saved. Now we're going to go to a new DeviceNet, and we're going to go and go online again. So we're going to go looking for our DeviceNet. So there's the main DeviceNet, not the subnet, and we come up on it, and it's going to browse. It's going to take a little while, so I'm going to go and pause this guy until it gets done doing what it. Okay, I'm back. You didn't know that I was gone because I was on pause, but the RS network for DeviceNet has found everybody, and we'll get rid of the people we don't really care about because we don't need them all. And I used 30 last time, so I'll use 30 this time. So now I have I'm sitting like that. Okay, so first thing I'm going to do is look at the properties of the DeviceNet PointNet scanner guy. And I see that it has inputs, it has parameters. Oh, we got to upload from the network. Okay, so moving back. Network, upload from network. Okay, so this brings everything in, so the computer program is happy to know what's out there, sitting on the plant floor. Alright, so everything's there, that's fine. Now we're going to look at the .io device, and we say, well, you know, that doesn't seem to be much there. We have some baud rate, we have some something going on, whatever it is. The point of interest is here, the device bridging. This is where we need to find the associated file. Now the associated file is the subnet that we already made. So we're going to put the subnet that we made originally into the there we go, and we've applied that, and everything is fine in the world. And then we're going to come over and look at 30 again. We're going to look at the parameters at 30, and I'm going to make sure that the basic program parameters are COM-port and COM-port. I'm going to do another upload from the network and make sure that we didn't mess something up here. Okay, now we're going to look at 3063, our DeviceNet scanner, and we're going to look at its scan list, and we're going to remove node 49, which isn't there, and we're going to put the power flex on first, because if we'll do it twice. So we're going to put the .io on first, and then the power flex second. Okay, so if we do that, now I'm going to look at the input outputs. It's now put the power flex at data 0. The power flex at data 1, but the program we wrote for project 1 had it at data 0, so if we'd have to modify that program to allow that to happen. So what we're going to do is we're going to remove them and put them back on, and we're going to put the power flex on first and the DeviceNet scanner on second. And then when we look at those input outputs, we see the power flex is now in the inputs and the outputs in position 0, data 0, which is the way the program was written in project 1, and that'll cause us the least amount of hate and discontent. We go to look at the input-output parameters, and we see that we're okay. All right, now I've secured the noise in the other room, so we're going to apply this, And so now we've applied those to the device, and we hear our motor is speeding up on us. So we need to go and do something about that probably. Okay, so what we're going to do is File, Save As, and this is going to be Project 2. DeviceNet Doug. Alright, so that looks good, and now he's saved. Now we're going to come back up into our original program that we had, which might be that one. No, it's not. Okay, so no, that's not it. So we want to File, Open, maybe it's that one. Okay, so this is our original DeviceNet program that we had, and now there's things that have been changed. One of them is that the program in the DeviceNet scanner needs to be changed. So when we look at this DeviceNet ControlNet thing, it says that I put Project 1 DeviceNet scanner. I need to have the Project 2 DeviceNet scanner in there. Apply. Okay. Alright, so now we're going to go and download this file. Well, before we do that, we're going to look at it. Alright, well, it seems to all be there. Okay, so we're going to download the file. No, we're not. We're going File, Save As, and we're going to call it 2. So that, so there we go. Project 2. Now we're going to download it. Okay, well, the computer, PowerFlex is turned off and has gone into default. Back into run. We see the device is not ready, is not active, and we see that it's also faulted. So what we're going to do is toggle the bit that clears the fault. And then we're just going to leave it on, so every time that it gets a fault, it will unfault. Alright, well, that seems reasonable. Now, we're ready, but we're not active. We go to Start. And now we see that we are ready and active. Ready, active, and at frequency. We go to Program Tags, and we change the reference to the 600, and we see the speeds coming up. So we're now controlling it just like we did in Project 1, but we want to control it like we do in Project 2. Alright, so we'll come back to the main routine, and we will hit the stop button. Toggle, and we're going to stop it. Now, the next issue is, where are the switches on the point I/O? That is something that we're going to have to figure out. So we're going to come into the controller tags, and the input of the controller tags, and the data of the controller tags, and we know that they're at data 0 because that's where we put them, in data 0. That's where they have been mapped. So they've been mapped into data 0, and now the issue is where are they? So what I'm going to do is I'm going to pause for a moment and turn one of them on. Data 0 is where the power flex is mapped. So data 1 is where the switch is. So that switch that I just turned on is right there sitting in dot 16. I'm going to mark it as stop. So that's going to be my stop switch. And what I'm going to do is I'm going to cycle that switch, and you're going to see that 1 becomes a 0 as I do that. So 16 became a 0, and now I see that 18 has a 1. So I'm going to use that as my start guy. And then I'm going to go and cycle another switch and see where it is. And I see a 1 in 17. I'll call that forward. See a 1 in 19. I'm going to call that reverse. Okay, I see a 1 in 24. I'll call that speed up. And I see a 1 in 25. I'll call that speed down. Okay, so now I've labeled my point IO as to what they are by turning them on. Now I'm going to use the point IO in the main program. So we come back to the main program and we say, well, we have this stop command. Okay, well, we're going to come offline and we're going to change the stop command. I'm doing a left mouse click. I go to the down arrow. I get rid of the program tags by clicking on a program. I'm looking for inputs, data, and I'm looking for the data 1 guys because that's where the point IO is. And I don't really remember where it is, but because I described it, when I get to it, it'll say stop. So 16 says stop. I'll click there and that'll be good. And then we have a start command. I'm going to do the same thing. I'm going to go and look and get rid of the program tags. Go to the inputs, the data 1, down arrow, and I want start. There's start. Okay, I don't have one for am I in the right spot? Yes, I am. Okay. Then I want a forward command. So I'll go to programs, input, data 1, and I'm looking for forward. There's forward. Then, because I was using the same bit for forward and reverse, I'm going to have to change this to a normally open contact. I'll get rid of that guy. And we'll go find the reverse guy. get rid of the program tags, look at local input, data 1, and find the reverse guy. Be nice if I wrote out reverse. That would be okay. So now we have a way to start it, go forward, go reverse, and what we're going to do is we're going to download it the way it is, and we're going to worry about the speed later. So we're just going to see if we can control it using those commands the way they are. And what we'll do is we'll put you on the program tags. We'll put your speed reference as 600, and I will go and turn those switches, and we should see that that 600 is changing in the feedback. So up here in the feedback speed, we should see it going up and down. Silly me, I forgot to clear the error. So we're going to come back to the main routine, and we're going to see that we're faulted. So that I don't have to worry about that again, we're going to come offline, because clearly we're going to go offline several times. And we're going to make this a normally closed contact, and we're just going to clear the fault all the time, because every time we download the program we're going to get a fault, and if we don't clear it then we're going to be in the wrong place at the wrong time. So we're going to go download that program. And now we come back up and we see that we're not faulted. We're not faulted, drive is ready, and we come into there, we come up on speed reference at 600, and we are ready to go. Okay, so now I'm going to go use the switches and see if I can control. So you should have seen the speed going up and going down and all those other cool things. So now what we have to do is figure out how we're going to make the speed go up and down. So that's going to be our next job in the program writing. So we come back to the program, and we're going to come offline. And prior to putting the speed reference in to the outputs, we're going to go in and add some runs. 1, 2, 3, 4. Oh, wrong spot. Okay, and so now we're going to have a speed up and a speed down button, and in the 5000 program we run, we use the time base in the status bits, and we used a one-shot rising. In this particular program we don't have any status bits, So, but we would like a timer. So we're going to have a timer. We're going to call it something cool like timer. And then the data type of the timer is going to be timer. Oh, isn't that convenient? So now we have a timer. And if we look at it, we see that it has presets, it's got an accumulator, it's got a timer enable, a timer timing, and timer done bit already there ready to be had. Okay, we're going to need, well, we're going to use the reference speed, drive reference speed as how we're going to change the speed. So that's going to go up and down. Okay, so that being said, back to the main program, and so we'll put our timer in. Timer, and we'll have a timer done, timer, and its name is timer, and the preset of the timer. This timer goes in thousandths of a second. So if we put in a 10, that would be 100th of a second. If we put in 100, that would be 1/10 of a second. Okay, so 1/10 of a second, and we're going to add up to 600, and that should be okay. Okay, so we're going to put in 1/10 of a second, and we're going to have a speed up and a speed down. We remember that they are in the inputs. Input data 1. Where was speed up? There it is. 24 is speed up. And then we'll go get the other guy. Data. Get rid of the program tags. Input data 1. And there's speed down. So now we have a speed up and a speed down, and we're probably going to want to add, so we'll go get an add instruction. Math. Okay, so there's an add instruction, and then we're going to want a subtract instruction. So we're taking this speed reference, drive reference, and we're going to add 1 to it, and we're going to put it in speed reference, and we're going to take the speed reference and we're going to subtract 1 from it, and we're going to put it in speed reference. Now if I could get the right guy. I'm going to put it in speed reference. Okay, now we're going to throw in a limit instruction. Okay, so I'm going to limit, and the test is going to be the speed reference. And when I'm adding, I can go between 0 and 599. And when I'm subtracting, I can go between 1 and 600. And that looks like all I'm going to need. So I'm going to cut this particular run out of there, and I'm going to go. Oh, before I download it, I want to do one more thing. When I hit stop, where's stop? When I hit the stop button, I'm going to want to change the speed back to 0. So I'm going to want to clear the speed reference. So now the issue is, do I have a clear command? And and I don't see one, but I do have a move command. So what I'll do is I'll put a jumper around stop. What is this doing here? I'm going to put a jumper around stop. And then we'll do a move, and I'm going to move 0 into the speed reference. So when and it's not going to let me do that. Okay. No, it might let me do that if I had the move command in the right spot. Alright, that's fine. Alright. So when I hit the stop button, I go back to 0 speed. Alright. Now I'm going to go and do a download on that. I'm going to go back to run. My fault is going to clear because I put a normally closed contact in default. My drive is ready. I'm ready to go. And now I'm going to go and put you on the program tags. And you ought to be able to see that I'm ordering it to go forward. Where's my order to go reverse? Oh, I don't have an order to go reverse. Because all those orders are coming from someplace else. So the only thing you're really going to be able to see is the speed reference and how it's going up and down in speed, and whether or not I'm running or not, or whether or not I'm ready. So right now speed reference is at 0 because that's where it's at. And now I'm going to go. What you couldn't see is that although you did see, you see the speed going all the way up and all the way back, but when I hooked on the speed up and down guy, it went all the way up and all the way back. It didn't do what I wanted it to do, which was follow the speed. So I got a problem in the main routine. So let's see if we can figure out what that problem is. And the problem is I put in the speed up and speed down, and I put in the limits, but I didn't put in the timer. I wanted a timer there because as soon as I hit the speed up button, this guy's going to add every single scan. It's only going to take 600 scans to get to 600. That's going to happen almost immediately in real time. Okay, so what we're going to do is we're going to go back and add the timer done bit, so that it does what I wanted it to do. That's why the only reason I put the timer there is so that I could use the timer done bit to control the speed right. So there's my timer, and I want the timer done bit, and I want it there. And now I'm going to download that guy. Alright, so we're downloaded, we're in run, I'm back on my program tags, and now I should see better control of my speed. Well, silly us, it still isn't working. Did you figure out what I did wrong yet? We'll come offline. We we never reset the timer. The timer is done and it never is undone, right? Yeah, so we forgot to reset the timer. So we'll put a timer done bit there. And now when the timer is, let's undo that. All right, put the timer done bit there. And then as long as it's not done, the timer is running. As soon as the timer gets done, the timer resets. And now with it reset, now these things aren't closed all the time. Okay, silly us. Now you know why I put the normally closed contact in there for the clear fault. Otherwise, I'd be running around with faults all the time. All right, now we see the timer is timing until it is done, and then it resets. So that's a good deal. Now we'll come back on the program tags and see if I have better control of my speed. Well, you notice that our speed only went up 8 hertz as I was counting to 10 on a 10 count, and it should have gone up to 60. So we need to go about 10 times faster almost. So we're going to come offline, going to come back to the main program, and we're going to set the timer preset at 10. Why don't we try 12? Yeah, 12 might be better. All right, so we're going to set it at 12 and then download it. We have a 10-second ramp in the PowerFlex. It should take us 10 seconds to get all the way to 60 hertz. That's what we're trying for. Okay, so now we'll try it again. Won't be any good looking there. Yeah, we can leave it there because now we can see the speed reference. We don't have to go to program tags to see the speed reference because it's going to tell us what it is right there, what speed I'm going to. Okay. So that looked very nice. The speed went up, the speed went down. When I let go of the speed up or speed down, we stopped at where we were, and we seem to be following quite well. So with that, that ends the video of DeviceNet Project 2. And if you look at DeviceNet Project 3, you'll find out that it also does DeviceNet Project 3, which is kind of cool.